today we'll look at a program to find whether a number is prime or not. Prime number is a whole number greater than 1 which is divisible by 1 or itself. So number like 1, 2, 3, 7, 11. You see these numbers are divisible only by 1 and itself. It's not divisible by any other number. Like if you consider a number like 8, it's divisible by 2, 4 and itself, right? So these are prime numbers, and then 1 is not a prime number. Negative numbers are not prime number because they are whole numbers greater than 1, and 2 is a prime number. So how do we find if a number is prime? First we'll have to loop through it. There are two ways of doing it. We'll look at the easy way first. We'll just loop through the numbers, starting from 2 to a number less than the number, 1 less than the number, and see if it's divisible. If it's divisible, we just break because we know it has a multiple and it's not prime. And also we'll put a condition that it is greater than 1. Okay, so let's start. So if the number is less than or equal to 1, we know that it is not a prime number. So we will directly print it out. Number is not a prime number. Else we will check, okay, if the number is prime. So for that, let us loop integer I is equal to 2, I less than the number plus plus. We will use now the modulus operator. Okay, if it is completely divisible, that is the number is not giving any remainder. Okay, this means that when number is divided by 1, divided by 0, what is the divided by I, what is the remainder? It should be 0. It's completely divisible. If that is the case, then number is not a prime number. Okay, and we'll break because we don't need to. It'll be more efficient. There's no need to waste time to do multiple iterations. Also, we can put a count, okay, in the end to determine if it's prime. So once the loop is over, let us increment the count here. If the count is equal to 0, it means it's a prime number. Okay, so initially it will check whether it is less than or equal to 1, which means it's not a prime number. We don't need to spend any time doing any calculation. On the other hand, if it is more, we will loop and check if it is divisible by any number between 2 and the number less than 1. So here, if it is divisible, we'll determine that it's not a prime number and break, and in the end, if the count is 0, that means it has never gone into this, it has never passed this condition, so it is a prime number. Okay, so let's run this. So 7 is a prime number. Let's look at 9. So this is not a prime number because it is divisible by 3. So it is not a prime number. Let's look at 1. Not a prime number. Let's look at a negative number. Okay, so this is working as expected. This is the simple method to find whether a prime, whether the number is prime or not. There is an more efficient way to find it, and we'll look at it now. The more efficient way, instead of looping to number, we will loop to square root of the number. And why do we do that? Let's try to understand logically. So if there is a number which has factors which is not prime, okay, it will have some factors a and b. For example, 8, it is equal to 2 into 4, or 4, which is equal to 2 into 2. In this case, one of the factors will be greater than 2, and it will be less than or equal to the second factor, and they both will be less than n, right, the number. So here, if we consider only this part of the relation between the multiples, the a is less than or equal to b. Okay, multiply both sides by a, and multiply both sides by b. Okay, so if we combine both of this together, we have a square of a which is less than or equal to a into b, which is less than or equal to b into b. And now if we take a square root, it means a is less than equal to the square root of a into b, and it is less than or equal to b. Okay, so this is the relation. So instead of looping through all the numbers till n, all we have to do is check till the square root of a and b. If we find any multiple which is a, then we know that it is not a prime number. So in this case, like 2, if we consider the example of 8, which is 2 into 4, it is less than or equal to the square root of 2 into 4, which is 8, is less than or equal to 4. So this number will definitely be 2 point something. It is less than square root of 9, which is 3, right? So we can make this very optimized by just checking if we have a multiple till the square root of 8, the square root of that number. Okay, so with this logic, we will make the second way to find if a number is prime. To the logic, all we have to do is put the square root here, and remember the condition is less than or equal to. That's why we'll have to make a less than or equal to condition here. Okay, and we'll run this again. Okay, let's consider other numbers. 7 is a prime number. Okay, 9 is not a prime number. Okay, and let's say 21 is not a prime number. Okay, let's consider 17, which is a prime number. Okay, so you've seen different examples. So just by using the square root, we've reduced the number of iterations, made this program faster. So this is another way. One is of course going through till the number -1, or taking the square root. Now we can try one variation in this, that instead of taking a number, take a range of numbers and find all the prime numbers in that range. So I'll put the solution in the description, but you can have a go at it. Take a range of number, let's say numbers from between 10 and 20. Find all the prime numbers between 10 and 20.